All right.
That's what you call being a tryhard.
Well, you win money.
So now section 3, we're going to start working on problems that involve what we're doing in section 2. So right off the bat, a car drives up a steep 10-degree slope at a constant speed of 15 meters per second, 15 meters per second in miles per hour. Again, double it and then add a little. So we double 15, we get 30, add a little, probably going around 35 miles an hour. So after 10 seconds, how much height has the car gained? First thing we're going to do is draw a picture. So our coordinate system here, now we're going up a steep slope at a constant speed of 15 meters per second. We might consider tilting the axes here, but I'm not going to do that. So we have our steep slope.
Don't tilt it.
So no, we're not tilting this time. We have X and Y this way, 10-degree slope, like so. We have a car, amazing vehicle.
Truck's better.
All right, and then later on, we're up here. I'll probably never be able to repeat this amazing, oh, look at that. Okay, so now in my picture, what's going on? We have right here
Looks like a little bug.
a velocity going up the hill. Now, if I break this into components, there'll be a v sub x and a v sub y. Okay? But the way that I drew that, it doesn't do me any good. What I want to do is I want to put that v sub y over on the right-hand side so that I form a right triangle here. And then my 10-degree angle is down here making a reference angle like that, okay? So my picture is giving me every bit of information that I need to be able to solve this problem. So now I want to write down all of the information that I have in the beginning. What's my initial position, x sub I?
0.
Okay, fine. X sub I, 0 meters, my initial position. What about my y sub I? I haven't climbed anywhere yet, right?
0.
0. Okay. What's my initial velocity? V. So V sub I. Actually, my velocity is not changing, right? So it's
Yeah,
just
so
V.
it's-
We're not going to call it anything. It's just V. Is 15 meters per second. Okay. What else? Time?
10 seconds.
Time initial
0.
is 0 seconds. Time final is 10 seconds. Okay, what do I need in this problem to be able to solve it?
The C, or the B, the hypotenuse, I think. No?
No. What's the question asking?
Height has it gained.
How much height has it
Y
gained?
final, Y.
So I need y final, right? So I know y initial is 0 meters. I need y final. How am I going to get y final?
Using a formula.
Oh yeah, using a formula for sure, but what do I need to know before I can use some formula to calculate y final?
How much you move per second?
I know time final. I know y initial. What do I need?
Oh, isn't it just height for Y final?
Yeah, it's the height. And by the way, this is why I didn't tilt the axes. If I tilted the axes, y would be in a strange direction. If I leave the axes the way that I did, y is straight up. And that's what I needed to be able to answer this question, okay? I need velocity in the y direction.
Oh, yeah.
If I can calculate velocity in the y direction, velocity in the y direction, then I will be able to say, well, for 10 seconds we were going this speed in the y direction, so I went this far in that amount of time, okay? So I need that Vy component. Does that make sense?
Yeah.
Okay. So now that I understand that, how do I calculate V sub y?
How much height you gain per second?
Look at the picture. How can I get V sub y?
It's v sub y, so you have v sub x.
I have V,
Oh, you have the hypotenuse v and delta
and I have the
meters.
angle.
So you can use
V sub
So,
y is
sine.
the
Sine.
opposite,
Yeah.
and we have the hypotenuse, that's sine. So sine theta equals V sub y over V. So that means V sub y equals sine theta times V, we'll write in the front. So that is V, which is 15 meters per second, times sine of the angle, which is 10 degrees. Okay, make sure you're in degree mode on your calculator before you do this. And what do we get for V sub y?
.6047.
So 2.6 is what we'll say, meters per second, but use your calculator's answer to do the later calculations.
Yeah.
So now we know how fast we're going up.
So you just times it by 10, so it'd be 26 meters.
So then what is our formula for delta y?
That's what equals negative y minus what?
V sub y delta t.
Oh, v sub y delta t. Oh,
Distance equals rate times time, right? V sub delta y is the distance. V sub y is the rate, and then delta t is the time. So delta y equals V sub y, which is 2.6 meters per second, times the change in time, which is 10 seconds. Use your calculator's answer though, not 2.6. What do we get?
How many seconds was it? 10?
26.04.
Yeah. So we get 26. What?
Meters.
Meters. There you go. All right, the next problem, a crate slides down a frictionless, and frictionless you'll see a lot. It just tells us it's smooth and we don't have to worry about any kind of extra force situation applying to this. So frictionless ramp tilted at an angle theta. The crate accelerates due to the action of gravity, but it is constrained to accelerate parallel to the surface. What is the acceleration? Okay, so this is your first tilted axis problem. So first, we're going to draw the ramp. So the ramp is tilted at an angle theta. We don't know what that angle actually is. So here's the ground, and the ramp is tilted at this angle theta. Okay, now the crate is sitting on that ramp, and it's sliding down. Okay? So what we want to do is tilt the axes so that the motion is a little bit simplified. So the y-axis is going to come up here, and the x-axis is running along the ramp. Positive x down the ramp in the direction of motion to also further simplify the problem. Okay, so now we have motion down the ramp.
No friction.
There's no friction, but we do have acceleration. So acceleration is coming off of the center of the box straight down That is acceleration due to gravity. Okay? Now, what is the acceleration of the crate? All right? There's no other accelerations going on here because we're not pulling on the crate. There's no friction on the crate due to the surface of the ramp. All we have is gravity, acceleration due to gravity, which is straight down. Okay? So what we need to do is break gravity into components. There's a component that's going to go along the y-axis, and there's a component that's going to go along the x-axis. So if I look at this vector, the g vector, there's the y-axis lives like that, and the x-axis lives like that. Okay? Where is theta going to be on this graph?
Would it be on the same side G is?
Like where g is?
Yeah.
So in here?
Yeah.
Yes, correct. That's where theta is. If you kind of follow through with geometry, if you use geometry, you would see that geometrically that's where theta is on that drawing. Okay? If you use logic instead, if you consider decreasing theta on the ramp, if we just start dropping this ramp down, what happens to this angle here? It starts to get closer and closer to the y-axis, right? So as we close this angle down, this angle closes down until eventually this angle is down to 0, which means that the gravity vector eventually gets down to the y-axis, okay? Has to be perpendicular, has to be centered towards Earth, which means it's going to be pulling straight down, okay? So logic also leads us to believe that this theta right here and this theta right here must be exactly the same angle, okay? So good. Now that we know that, we can create a right triangle here and say that whatever the gravity component is here is the same as the gravity component here, and now we have a right triangle. So the gravity component in the y direction and the gravity component in the x direction forms that right triangle, okay? So we have g sub y along the y-axis on the tilted axis, and we have g sub x along the ramp, because this g sub x is the same as this g sub x. All right, so what is the acceleration down the ramp? It's g sub x. So we have to calculate that g sub x using our right triangle that we just created. We see where theta is, and we see where g sub x is. So what's my equation going to be? Which trig function do I need?
Oh, word problem, because it's all letters. Sine. Opposite of hypotenuse. Because hypotenuse.
It is the opposite, yep.
Yeah.
So that's what?
Sine?
Sine theta equals. Now, I don't want to use g. I want to get rid of that, and I'm going to get rid of that. This is the acceleration in the x direction because it's no longer g.
Oh,
Okay? So g is the only thing that points down towards the center of the Earth.
So negative 9.8.
So, nope, I don't want to use 9.8 either. So I just want to use a.
A.
So we have a sub x over
A.
g is what pulls us down towards the center of the Earth, so g.
So don't change the.
No, don't change the g. Okay, so now solve for a sub x. We have a sub x equals g sine theta. And that's it. What is g?
9.8.
G is 9.8 meters per second squared. Not negative. G itself is positive.
Yeah.
Okay? So then sine theta, whatever theta is. Now, would this acceleration be positive or negative based on the way we have our axes assigned?
Positive.
It would be positive because we assign positive x
To the
in
right.
this direction. Okay, so we're accelerating positive down the ramp. Now we don't know what theta is, but we do know what g is. This is our answer right here. We don't have any numbers to plug in. That's it, we're done.
Yeah, I was gonna say, it looks like there's no number, so we only find like a defined answer.
Yep, that's it. That's all we had to do.
That didn't seem terrible.
Okay, the maximum possible ski speed for a skier. So the Willamette Pass Ski Area in Oregon was the site of a 1993 U.S. National Speed Skiing Competition. Skiers started from rest and then accelerated down a stretch of the mountain with a reasonably constant slope, aiming for the highest possible speed at the end of this run. During this acceleration phase, the skiers traveled 360 meters while dropping a vertical distance of 170 meters. What is the fastest speed a skier could achieve at the end of this run?
So vertical distance of 1.
So we know the
So we
distance
know-
they traveled, so we know the length of the ramp.
So we know
So
A
that's
and
360.
A sub Y.
All right, what should we do first?
Make a triangle.
Yep. So
Make a graph.
we're drawing basically what they went through. They told us they had a vertical distance of 170 meters. That's this.
A sub Y.
And then are they
We
talking
have
about
A,
360?
360 as the hypotenuse thing.
The skiers traveled.
Well, that's the
That's
length that they
this.
told. Yeah, that's that distance.
Yep.
So then we do that squared minus that other one squared, and you find the last leg for.
We're gonna.
Well, we could, but we don't need to necessarily, maybe.
Yeah.
Now, did they tell us this angle right here?
No.
No, so we can call that theta. That'll be a reference angle. This is a right triangle.
We can find the. I think.
So the skier would start up here. Right, we're skiing. Okay, and then we're gonna ski down the slope and end up down here. Okay, on this skier, what's going on?
Gravity.
Down.
Gravity's pulling down.
Straight down.
So we would tilt the axis for it.
Tilted axes, okay. So then we're gonna call this X, which makes Y perpendicular up here. So then the skier is doing what as they go down the slope? What's pulling them down the slope?
Gravity.
Just gravity, just G?
And
The trees.
Is it full on G?
No.
it's
What
just
is it?
Y.
Acceleration.
Acceleration in what direction?
The X.
The X direction. So we're gonna have a component of acceleration from gravity,
So it's AX.
A sub X, pulling them down the slope. Okay, and so then A sub Y would complete this right triangle right here. There's your right triangle. And where is the angle theta in this?
Top left.
Top left?
Yeah.
Or theta would be in the two, the gravity and the.
And A sub Y.
Yeah.
Yep, it's right here. In the other one, I drew the other right triangle. I'll go back to it real quick. I drew this right triangle,
Oh, okay.
but it was still where the A sub Y and G came together.
A sub Y, G.
Okay? All right. So now, what do we know?
The distance traveled in the X direction.
Okay, so we know delta X is 360 meters.
We know G.
Okay, G is 9.8 meters per second squared. What else do we know? What are we looking for?
Fastest speed velocity.
Fastest speed. So we're looking for what?
Velocity. Velocity.
Which velocity?
Final.
Final. What's velocity initial?
0.
Okay. 0 meters per second. And velocity final, we don't know. That's what we're looking for. Okay, and what else don't we know? Anything else we don't know?
AAY.
Or a sub x, right?
Right.
Do we need to know a sub y here?
No.
A sub y doesn't do anything for us.
So we need
It just
a sub
sticks
x.
us to the hill. A sub x is what pulls us down the hill. Okay? So a sub x is something we need to know. We also don't know delta t, or do we? Did it tell us how long it takes?
Yeah.
No.
I don't think so. So delta t, we don't know that either. Okay, we may not need to calculate time.
We're only trying to find a sub x.
We're only trying to find a sub x, right? So, actually, we're trying to find the fastest speed that we're going down the hill, but we will need a sub x to do that. Okay, so we need a sub x. We might need to calculate theta. We probably should calculate theta. How should we do that?
Opposite over hypotenuse. So so 170, or the inverse of sine is 170 over 360.
Sine theta equals 170 meters over 360 meters. The meters are gone. So
Inverse of sine.
theta equals inverse sine, oops, not equals, of 170 over 360.
28.
Exactly 28?
No, 28.1786.
36?
86.
86? Okay. Obviously, that's not significant figures, but we don't care because that's not something we need. All right, now what?
Yeah.
We have the angle.
The angle. So theta goes into that, the theta in there, right?
Yeah, so now we can calculate a sub x now that we know the angle.
Because we have hypotenuse and, no, we have g.
We know g.
And the degrees, so just 5.
Okay, so how do I calculate a sub x?
Sine. Right?
Sine, yep. So sine theta equals, what am I doing?
AX over g.
Okay, so a sub x equals g sine theta. That would be 9.8 meters per second squared. Sine of the 28 blah 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 that we just calculated. What do you get?
I don't think that's right.
What'd you get?
Do you multiply by the degrees?
Sine of the degrees you just got.
Yeah. Oh, sine times
9.8 sine 28.
28 point blah blah blah.
9.8 sine 20 point. Oh yeah.
Yeah.
And so then you get a of x equals.
It's 4.62.
4.62 what?
Kilometers.
Kilometers. Meters. Meters per second squared.
It's an acceleration, meters per second squared. Okay, so now we know the acceleration, but that's still not what we're looking for. What are we looking for?
Speed.
The speed, the final speed. So I need an equation that involves velocity final. It could have velocity initial in it. It could have acceleration. Probably does have acceleration.
No.
We know the delta x.
So v sub f squared
Okay.
equals v sub I squared plus 2a delta x.
Perfect. What's vi squared?
0.
Okay, so this term is actually gone. And so I solve for v sub f. I'm just going to square root both sides. And I have v sub f equals square root 2 times our acceleration.
Which is 4.62.
Of course, you're using your calculator's answer there. Times the delta x, which was 360 meters. Meters times meters is meters squared, so our units are meters squared per second squared. When we square root, we'll get meters per second. What do you get?
57.
Exactly 57?
57.7235.
So 57.7 for significant figures. Meters per second. This is their maximum speed. They cannot physically go faster than this because we are ignoring air resistance, we're ignoring friction, we're assuming that this is a straight shot down the hill. They cannot go faster.
Does weight do anything?
Good question. Does weight do anything with this? No,
If you were to,
it doesn't.
Really?
It doesn't. Weight has nothing to do with it.
How so?
It doesn't. It doesn't matter what your weight is. This is your maximum speed.
Isn't it because it's
hard to
terminal velocity?
Answer me this. If I drop a rock and a hammer, which one hits the ground first?
A hammer.
They both hit the ground at the same time. Does weight have anything to do with it?
They hit it no
It's
matter
air
what.
resistance.
We're ignoring air resistance. Does weight have anything to do with it?
no,
No.
because bowling ball versus feather.
That's right. Same thing, okay? But if we throw air resistance into it, then yes, weight will have something to do with it.
Oh, okay, but we.
Air
don't
resistance
have
has something to do with it, okay? So that's why you see the Olympic skiers wearing these skin tight, very aerodynamic suits and things like that. Because then they're getting a slight edge over the next person if their suit is a little bit better or their frame is a little bit narrower or whatever, okay? But this is, the physics here, the math actually prohibits them from going any faster than that. They can't do it.
Oh, so that's.
So they just want to get as close as they can to that number.
Oh, okay.
Okay, so now the speed of a roller coaster. Classic wooden roller coaster has cars that go down a big hill first, so then they get up to speed, and then they ascend a second hill with a slope of 30 degrees. If the cars are going 25 meters per second at the bottom, and it takes them 2 seconds to climb this hill, how fast are they going at the top? By the way, that last problem, 57.7 meters per second, what is that in miles per hour?
100 and something.
Double it and add a little. 57 double is 114, add a little, they're going about 120 miles an hour. Would you want to go much faster than 120 miles an hour skiing?
No.
Probably not, no.
Not without something protecting your face.
Yeah, that's crazy. So,
Imagine if a bird came in front of you.
all right, back to this problem.
Yeah, you're just gonna get a red mist.
What do? We're going up a hill, right?
Mm-hmm.
Okay, so we're gonna draw a hill going up. What angle are we going up at?
30 degrees.
Okay, so this is a 30-degree angle apparently. Now, are we gonna tip our axes?
Yes.
Yeah, we should. Okay, so this is the x-axis now. And that means this is going to be my y-axis, which I'm not too concerned about because we're rolling on a track, okay? We're not going to do anything in the y direction, which is fine.
Hopefully.
Yeah, hopefully we're not doing anything in the y direction. Okay, so now the cars are going 25 meters per second at the bottom. So that we can write down, we have t sub I at the bottom would be 0 seconds. T sub f,
It's 2 seconds.
2 seconds. We have v sub I at the bottom,
Is 25.
25 meters per second. Very fun speed.
F is,
V sub final at the top, we don't know. Now, x sub I and x sub f.
we know x sub I.
X sub I would be 0 meters. X sub f, we don't know. Okay, we also don't know the acceleration in the x direction, right? A sub x, don't know. A sub y, we don't care.
Yeah.
If we have an a sub y, we have bigger problems, so
G.
we're not going to worry about it. Now, the car. Where is the car?
At the beginning.
Maybe we're somewhere along the way, right? Okay, so how does gravity go on the car?
Straight down.
Straight down, always straight down towards the center of the earth. Okay, so this is gravity, acceleration due to gravity. We can just call that A. Now, how does acceleration along the track go? A sub x.
Across the x-axis.
Which way?
Right. Because they're going up.
Are we accelerating up the track or are we accelerating down the track?
Up.
Gravity is pulling us backwards. We're slowing down.
So slowing
We're
down.
going up the track, but we're slowing down. Gravity is trying to pull us backwards.
Oh.
This is acceleration in the x direction this time. And then acceleration in the y direction would be sticking us to the track perpendicular to that. This is my right triangle this time.
So now theta is right next to A.
This is my angle theta. This is the 30 degrees here.
Roller coasters are scary.
Roller coasters are awesome. If you think they're scary, you're in great shape.
Well, like, I always think that something's gonna go wrong and I'm just gonna fall.
Sometimes they do. Okay, so we need to calculate that a sub x. What do we do?
So we have theta. We need to wait. We have A. Yeah, we have A. 9.8.
Of course we have a, yeah.
9.8 meters per second. So
Okay, so
A sub sine theta equals A sub x divided by A.
all right, so
A sub x equals A times sine theta. And plug the numbers in, you get 9.8 times sine 30 degrees.
a is negative 9.8 meters per second squared, by the way.
It's negative now?
A is, yeah,
Why is it negative now?
because I'm using a.
Oh, instead of G?
Yeah.
Oh, okay. So negative times sine 30. Negative 4.9.
Okay, negative 4.9
Oh, because we're doing
meters per second squared. Now, if you didn't get negative on this because you forgot that we're using a or you used g instead, that's fine. But notice that a sub x is against the positive x direction. So this is where you would add in your negative sign to account for that. Okay, so our acceleration in the x direction is negative 4.9 meters per second squared. What do we do?
So now that we have AX, we solve for.
We need final velocity, right?
Yes.
Okay. And we don't know the final x, so we don't have a delta x.
We need delta T. Oh wait, we have
Yeah.
delta T. So
We have
we'll
delta
just
T.
So we have
solve for
delta,
velocity.
so VF equals VI
Yep.
plus a delta T.
You got it. A sub x delta t. Okay, and so we have all that, right? Vf equals Vi is what?
0.
No,
VI 0? Not
Vi is 25 meters per second. Plus acceleration in the x direction, which was negative 4.9 meters per second squared. What is delta t?
2.
2 seconds. Okay, so what do we get?
$15.2
15.2.
meters.
Negative.
And are we liking that significant figures? I only see 2, so we're gonna go with 15 meters per second.
Would it be negative or positive?
No, I.
No, this is positive,
How would it be positive?
because that's a
included the
positive
negative
25
equation.
meters per second.
Pop me out of.
We're going up the hill.
But there's a negative in
This is negative, sure,
there. Yeah.
but we're going a positive 25 meters per second. We're going the positive x direction. So this should be a positive answer, and it is.
I'm confused as to how we got that. If it's by 2 positives and 1 negative.
Positive 2 seconds times negative 4.9 is negative 9.8. Positive 25 meters per second and negative 9.8 gives us positive 15. I don't know either. All right, the last problem, real quick. Block of ice slides down a ramp. For which height and base lengths is the acceleration the greatest?
I feel like it would be B.
Why is it B? You're right.
The ratio is
Because
1 to 2.
because it's still a decent height, then it stretches that out.
The ratio is 1 to 2.
The ratio of what is 1 to 2?
Height to base.
length.
Yeah, the height here to the base length gives us a bigger height to length ratio, which makes the height, this is steepest with B, which is gonna make it go faster. So that means we're getting a greater component due to gravity in the X direction than any of the other ones, which is gonna make us pull down the slope faster than the other ones. Correct, good job.
All the others, is there like